Welcome back to another episode. This week we are joined by two special guests for a conversation that dives into some big questions. Is AI truly creative? Is critical thinking at risk in the age of AI? And how close are we really to reaching superintelligence? What's holding us back?
I'm Giorgio Zinaro.
I'm Ivan Peña, and this is Bootstrap for Cash. Good morning, Giorgio. How are you doing today?
Yeah, not too bad.
Today we have a special episode. We are trying again new things, new formats, and it's going to be a conversational podcast about artificial intelligence, but not what we have done these last weeks. It's going to be more about speculation. I think it's going to be interesting. What do you think, Giorgio? How's your feeling?
Yeah, definitely. And I always love having guests and more guests.
It's going to be a challenge. We have today 4 people. We already have some technical issues, as usual, and let's hope that everything is recorded. So, said that, let's start with introductions. First, our dear colleague, Mauro Foresti, or Dr. Foresti. He doesn't know, but he has been part of this podcast. Well, actually, he knows, but he has been part of this podcast since the beginning, even before Giorgio and I started talking for the first time. If you listen to our intro music, Mauro is part of it. But yeah, Mauro is doctor from the ETH Zurich, right? And actually, what's the study exactly? Was it electronic, or was it exactly?
No, I studied electrotechnics in signal processing and speech processing and neural networks, actually.
Yeah.
And then the PhD was totally different. It was in biomechanics.
Okay. And you have, after all this knowledge you acquired, you moved to banking.
Correct.
But yeah, we met each other in our previous employer, and we worked for many years together. And on the other side, we have Juan Sanz. He's not a doctor yet. And I don't think he will. But he's working in big tech, really involved in the artificial intelligence. So Juan and I met many years ago, also in our former employer, right? And we worked together for many years, also tried to do to create a startup in Spain in mobility. Didn't work out because, startup was to share car. During COVID, maybe not the best time to share car. So it didn't work out, but here we are. And we also did some consulting together. We still have a company together. We are closing it right now, we're liquidating it. And I don't know, Juan, do you want to say anything else?
No, just that it wasn't a complete failure. Every time that you try a startup, at least you take with you all the lessons learned, which I think are quite valuable. But thanks for having me here today. Actually honored to be surrounded as well and invited by such a talented group.
Thank you. So let's start. So the format is going to be the next. We wrote some questions with some context, and I'm going to give this to the audience so that they know what we are talking about. You already know because I sent it to you. And then I will probably mention a name, and then we can start discussing the topic. So the first topic is about, is AI creative? The context is generative AI is now capable of producing text, images, music, and even winning at games that require strategy and foresight. So can we already say that AI has mastered human creativity, or is it just simulating it? Mauro?
Well, the first question is always, what is creativity? I was listening to an interview with the godfather of AI where he was talking about creativity just in a small sense, and he was explaining how AI can be superior than the human intelligence. And it was saying that creativity, in a sense, is trying to find analogies between different things. So, and also weird analogies. And then he was saying that actually we have, like, as a human, we have like 100 trillions of connection between the neurons, while nowadays AI has like maybe 1 trillion of connections. And so if you need to accumulate all the knowledge inside of just 1 trillions of connection instead of 100 trillions of connection, you need to start finding analogies between the different things, that between all the information that you gather. So because then you can store it in just a small subset. And so you need to find those analogies. While if you have many more connections, you can store it separately. So by finding those connections, you can start being creative, because you find analogies and you create new analogies out of it. So in a sense, if you replicate just the mind and what it creates, the different, let's say, creativity piece of art or new ideas and so forth, then if you are able to find more analogies, then you are also able to be creative. So in that sense, you could say it could be creative if we know what creativity is, and if creativity is what I said before, so finding analogies, then I would say, yeah, probably. And it's already doing that, because when also you were talking before about your intro of the song, it has creativity into it. Of course, it took it from other things that he heard and so forth, but that's also the human mind. When you start to be creative, it's like mixing all the experiences that it had. So in a sense, why not?
Juan?
Yeah, I completely agree here with Mauro. I mean, Daniel Goleman, for instance, some years ago, he came up with the concept of emotional intelligence as well. So we have discovered that we have more than one intelligence, right? It's not a mathematical one. So when we are talking about creativity, specifically in the area of art, right? Artistic creativity, we have to take into considerations as well human experience and emotions, empathy, and these are important factors, right, to take into consideration when we are talking about creativity. So I think at the moment, of course, I don't know what is happening in the research, scientific buildings of these big companies that are developing AI in those labs. But those models that are put for us to use are based on mathematics. And so far, they can try to mimic emotions, human emotions, but they are not basically human emotions. So in that aspect, I think that the expression, the feelings of I don't know, a painting painted by Picasso or by one of the artists is unique in the sense that it's the expression of feelings, emotions, experience, and that's still something that with AI or AI is not capable of it yet, in my opinion.
Giorgio?
You know what it's also really bad at, which is a very peculiar kind of creativity. Jokes, being fun. In fact, it is fun by being so unfunny. Like the way it invents jokes, it either needs to copy something 100%, because obviously a joke only works if you've got like everything figured out. You need to know how to get to the punchline, and you can't really variate it too much, or it makes up some jokes and has to explain to you why it's funny, and if you need to explain it, it was probably not a good joke to begin with. It's really curious how bad generative models are at that. I think I never found if there is much studies about it, but I think it's something that would deserve to be studied more. I think it probably says a lot about how the human mind actually works. As we know, I mean, AI is, of course, it tries to mimic how we think a human brain may work, although we also do not know that 100%. And so that's a best shot at it. But obviously there is much more to it. And yeah, still cannot do that.
Maybe, if I may, Giorgio, I was reading just as well to prepare the podcast how much we know about the brain. And in fact, actually, we don't know that much about how it works. So it's very difficult, right? When we are trying to create AI that tries to mimic the brain, create one that can, so to say, mimic the brain functions when we don't know them all. Like when we make jokes, like all the factors that are being considered.
Yeah, one thing that also I was thinking about, because if you look at, just as I said before, just modeling, mathematically modeling the connections and the weights and so forth. If you say just neurons, the brain is just a mass of neurons connected together, and it just functions because of the weights and the connection, how strong a connection between each neuron is. If you just model that, then of course you could say it's a simplistic way of looking at the brain. Because one thing that I never heard talking about is the biochemistry that you have in the brain. So I mean, even it's like all the hormones, a situation. Just think about, if you when you say also those studies, that if you look at if you drinking milk that is blue, how you react, or just because the wall is blue, how you taste an apple. It's different than if you taste it and you look at the green screen, or for example the temperature of the outside world. Is it 0 degrees, or is it 40 degrees, or the humidity, or also like for example also the hormones. Just look, for example, at a woman when during pregnancy and so forth. Those hormones, they just change the behavior. So there are so many factors that it's not just about the connection, but also about the biochemistry around the whole brain. So yeah, so probably also Picasso, like is he like drawing in England, or is he drawing in Malaga? Should be a difference on how he draws the painting, what colors he uses.
I'm going to try to connect this topic with another topic we had to discuss today, and so I'm going to give it a try. So for me, what's important, I was listening to another podcast yesterday, and they were talking about what's the definition of intelligence, right? Because now many people are discussing this topic. Like, how can we call something artificial intelligence if we don't have a clear concept of what intelligence is? And it seems that there is one from science, which is the ability to take your past, what you say, I think is similar to what you said, Mauro. You take past experience and you face new challenges in the future, and you solve them with that past experience by doing something which we computer scientists know as abstraction, right? We take what we know already, our knowledge base, which is programmed in our brain or recorded, and then by abstracting, we can solve problems that we never faced before and do something creative, come up with creative solutions to solve those problems. And it seems that what's defined as intelligence. And us humans are really good at it by taking a small sample of information, small compared to what artificial intelligence requires, right? Because keep in mind that models, even today, I mean, transformers are not, I mean, they are more efficient, right? And doing certain things and generating things. But at the end, they consume a huge amount of data, and they need that huge amount of data to learn. So one question the guy was saying is like, are you really intelligent when you know everything in your brain? You have in your brain everything, all the knowledge, human knowledge in the world. And then you are faced with challenges that are already solved by humans, but you know already how to solve them. Is that really intelligence? Because at the end, intelligence is taking that knowledge and facing new challenges that never happened before and try to solve them with creativity. But AI is not doing actually that, right? Or what do you think?
I mean, if I may, it goes a bit, I mean, from my my beginner understanding of AI and all the things. So I mean, what I said before of what I understood, it's like this knowledge. If you train an AI, it's not that it stores the knowledge as is. It just merges all the information and stores it as analogies, and then you could say it actually has seen much more, and it has created much more analogies to be able to keep all that information. So it is able to create more solutions that we could even think about, because it's something that probably we have never seen. So what I'm saying is, if you know like a whole library, you know everything, you know what happens in the past, you know all the research, you know everything. So, and you need to find like a solution between all that knowledge, but you created all those kind of analogies that you as a human, you never been able to see. So of course, as a human, you say, I'm more creative. Yeah, probably because you have more connections and something that we don't know, and just speculating here. But if we go by the analogy of I mean, if we go by the thinking that we say, it's the more you know, the more you're able to draw analogies from, because you know more. So in a sense, you could be even more creative, or you come up with solution that we cannot even think about because we don't have the knowledge, or we don't have that information to be able to draw conclusions from.
But still, see, that is far away from us humans. Like, it's really a simulation of our brain, or a simplified simulation of our brain, because there is some biology in our brains that is doing something that those models don't have, this biology methodologies or methods or functions. Because, as I said, for instance, a kid, let's put a kid. If you show a kid 2 cats, they will be able to recognize the third time a cat, or if it's not a cat, right? A kid. But for AI, we need millions and millions of pictures, so it recognizes the patterns to recognize a cat, right? So I guess this biology part that the models don't have is making us more efficient in this abstraction, right? And actually, us computer scientists, we are used to abstraction. I mean, we created computer programs, programming languages, which are basically abstraction. So we tend to abstract every time things to make everything easier and to come up with conclusions and new solutions to things that we didn't know before. And this comes to the next topic. So let's jump to another topic, which is the AI technical restrictions. Because it seems that new models, we remember when GPT-3 was released, was like a huge thing. But then now the moment we arrive to O3, and now O3 Pro, we don't see much of an improvement in the performance. And it seems that we are hitting some walls here. One of them is data scarcity. So these models already consume the whole human knowledge in the world, or at least the public one. And then we have Google, of course, that they have their own private databases. And that's why probably Gemini is so good. But we also have hardware limits, right? So for instance, the new tech giants are building massive compute clusters like Elon Musk with Colossus, right? Or forming alliances like OpenAI and Google. But to go beyond that, what people tend to call AGI or superintelligence, maybe superintelligence is more than AGI, I don't feel that the current models or the current architecture, like transformers, is going to be able to achieve this goal. And I think we need something else. And I was wondering, the question for this section is, how can we overcome AI current limits? Like, we have different things. For instance, quantum computing is coming soon, hopefully. And that could be one, at least for the hardware limits. Another thing could be like Juan said, we don't know much about our brain. Could AI help us to understand more our brain? And then maybe we can come up with mathematical models more similar to how our brain works? Or is the future maybe brain-machine fusion, like cyborg? Should we become cyborgs? What do you think, guys? Juan?
Okay, maybe I'm going to start by providing the technical restrictions that we have currently right now. So I see what's going on with enterprises, startups adopting AI/ML, and then maybe we can see later on what's going on in the future. At the moment, the problem that we have is first, of course, training those models require huge amount of energy. And we see right now that, for instance, in Europe, energy is quite expensive. So this is one technical restriction that we have, right? Energy is very expensive. We are also trying to create green energy, but so far, energy or green energy supply is not sufficient to supply all the energy consumption that we require. And on top of that, we have huge data centers that require huge amount of energy just to train models, and not only to train them, but also to evaluate them, and then later on for inference. This is a big issue. I mean, just to train one model like GPT-4, I was checking with ChatGPT, like it has over 1 trillion parameters. It requires the consumption of 1,000 US houses consumption a year. It's tremendous. I mean, we are talking about 1 gigawatt. So this is a technical constraint that, it's hopefully within the next years, we will find energy alternatives that are more efficient. This is something that, for instance, and I want to maybe remark it, in my hometown, Talavera de la Reina, Meta is opening a big data center. And the reason why is because Spain is making big efforts in green energy, right? But this is one of them. The second is that although we have those big models, we still lack compute resources to supply the demand of many customers, right? So to have a stable throughput for many customers that are worldwide, requiring sometimes near real-time responses. This is not there yet. And then we go into the next step, which is, of course, we want to have AI compute at the edge in the small devices. Those models are huge. So we need to find mechanisms to be able to optimize them so that they can run in your watch, they can run in your fridge, they can run pretty much in small devices as well, so that they can provide all the human needs or demands that we are having. So I think these are the most, let's say, urgent technical requirements that we need to address. And to do not forget, this is not a technical, but it's an ethical requirement, and as well how AI might impact the world. So in the European Union, we are very good in regulation. So now how regulation is impacting as well innovation, and how companies can adopt AI in a secure manner. This is also something important, which is a framework that will require probably a lot of research and assessment.
Just FYI to what you said, Giorgio and I are seeing this trend towards models running on devices, right? Many companies, big hubs, especially Google, are investing a lot of time on training and quantizing these models that you can run them on your own device, so you don't have to run them on huge cloud infrastructure, right? It was just as an information, so we can continue. Mauro?
I mean, would it be also one thing that, I don't know, I have no idea about it, but I was just thinking, if they run like in a distributed mode, why not train them also in a distributed mode? Because right now, if you think about it, all, as you said, Juan, they train their model like in isolation. And now you could say, but we have so many devices, you could start saying, yeah, it could be trained in a distributed mode. All the energy that is idle, all the energy that is being like, because I mean, maybe I'm wrong, I don't know the details, but as far as I know, also a lot of energy is being just burned, right? And now I can imagine that at some point we might start thinking about to use this energy in a sensible way, to reuse it in a sensible way.
Now that you mentioned distribution, it comes to my mind that another trend is agents, right? We are moving towards agents because we realize that foundational models cannot cover all the use cases that we humans can do by ourselves, right? So it seems that they move to this distributed model where you delegate each task to a different model running on an agent, and each agent is interacting with each other, coming towards a certain task. So if a certain task requires X, Y, Z task or subtasks, you delegate on those agents to do them in parallel, and then you come out with a final outcome, all of them together, right? But that's not actually what we describe as superintelligence, right? That's more like you have different people working together, but you don't have one person doing all of those things at the same time. So what do we need to move towards this goal of superintelligence? Giorgio?
Somebody mentioned earlier, I don't remember who did that, about a kid, how a kid learns about the world. I think there is this fundamental misunderstanding. Maybe it's not true anymore. Maybe people did understand that. I know that there was this misunderstanding for a long time that whatever you wrote, like in ChatGPT, in whichever language model, would not just become part of the training data, but would train the model immediately. And obviously this misunderstanding comes from the fact that the way LLM works is called a form of contextual training, if I remember the term correctly, which means that whatever you're writing in the context, in the messages, becomes part of the training data for the current execution, for inference. So it's got all the training that was done before. I remember we explained this better in a previous episode, in fact. So if you look back, you will find it. But got all the training data being used to create the model, so those patterns, that network, the analogies that we were describing earlier. And then at inference time, you are in a bubble. You have a copy of the model running just for you. You can write something. The model can operate on that data that you put in context right now. But once you close that tab, it's gone. It's not really gone. It's copied over. At some point, it will become part of the next training data. It can also become a summary that it is loaded in memory, but it doesn't matter so much right now. But the really important thing is the model is first trained and then you run inference on it. And we mentioned how a kid learns about the world earlier. And this is not how we work. It's not like when a kid becomes adult, they stop learning. They shouldn't, at least. Probably we learned a lot more when we were kids.
Now listen, I mean, if I can jump in right here, I mean, we have this situation at home. You know, I have a son, 8-year-old and a 10-year-old, and I see how they learn, and I see how they change, how they learn, and I think I'm pivoting. Not saying about it. I'm trying to put more emphasis on teaching them how to learn. So they need to learn how to learn, and you can even like reiterate it and say they need to learn how to learn. You know, it's like, because you do it a lot by experience. Like, for example, I give you a really quick example because we've seen it this year. I mean, Andrea, the bigger one, I'm not saying he's stupid or anything, or is intelligent. No, I'm not just judging him. But he wasn't bringing like the best of the grades. Although from the feeling, from my experience, he could do more. You know, because you see the kid, you experience him every day, in the morning, in the evening, and you start thinking, yeah, but maybe it's my impression because you're a proud father and so forth. And you say, hey, my kid is the best one and so forth.
You are a proud father.
What?
You are a proud father.
Yeah, but it is like that. I mean, every father thinks his kid is just the best, and that's how you survive, how you bring him, you shelter him and you protect him. And that's the way. That's nature. And then we were starting now saying, hey, maybe we really need to teach him, and he needs to experience. If you train the correct way, then you get good grades. And that's what we started doing. And suddenly the grades improved. And even he started to say, hey, I can do this. And suddenly, for example, in the last exam, he just did everything by himself. We let him do it. And he brought the good grade. And you start thinking, yeah, I mean, they need to experience it to learn it. And also this experience, this way of learning and experience, out of the experience that they learn, it's something that, how do you model that? Because it goes back, I think it goes back to what I was saying before, also the experience, the feeling of having succeeded in something. That triggers biochemistry. And that experience of the biochemistry, that also gets feedback into the brain, into the next experience or the next way that you approach something. So you have so many factors that we are not just looking at when we train an LLM or whatever kind of AI model that we are using, that it's like, I think it's a huge part. And if you are not taking in consideration that part, you will never reach the same, I say the same amount of reaction, of intelligence, or whatever, of expression of an AI, right?
It's actually interesting because in a way, this motivational thing that you use with your kid, right? Because at the end, he was motivated. When he was seeing results, he was motivated, and that was enhancing or empowering him to do more. But in a way, this is already modeled, actually. If you remember, you can motivate the models, the LLMs, to do better by certain tricks. And basically, either you threaten them, like saying, I'm going to kill you or something like that, and that motivates them to give better results, or you incentivize them by telling them, I will give you $10,000, this kind of thing. So those things are already modeled. So you can see like human behavior was already modeled into the models, and it's quite interesting. And yeah, but it's still missing this biochemical thing, right? Like the biology is still missing, right? And this connection. And I don't know how we are going to achieve that with mathematical models or representations. I mean, most of the things in nature, on physics and everything is modeled mathematically, right? So is everything in life around us, so can you model that mathematically, everything? What do you think, Juan?
I do not think so. Or at least there was actually a research I watched on TV on how people decide or how you fall in love with someone. I mean, there are thousands of factors that some of them, obviously, or many of them, you cannot control. Mauro was mentioning I completely agree with him. Chemistry, dopamine, serotonin. I mean, there are so many chemicals running in our bodies, and then you see someone, and then you decide, okay, or you don't decide, but your body decides for you, or your brain decides for you, this is the right person. I think this is very difficult to mimic. I mean, from my knowledge so far, from all the models that I have worked with and used, this is very far. It's impossible.
They didn't fall in love with you, right?
No. And not only that, not even sometimes sharing a word. It's just by observing, the thing is, like, humans do not communicate only with natural language. There are also many other ways of communication. And so far, these large language models have been trained with data that is available out there in the internet, but emotions, chemistry, the air, the weather, the sun. I mean, all those factors are not. Of course, we have literature about, Becker or Shakespeare, Cervantes, talking about emotions in their poems, in their novels, etc. But those are just words that if there is no human reading them, there is no feeling, there is no expression. So I think all those dimensions are not considered right now in AI models, and we don't even understand them all, right? Like what's going on in our body, but we just feel butterflies in the tummy, or when you're eating something, like for instance, I don't like certain food. There is no logic. I'm from Spain, and we have amazing fish, but don't ask me why I don't like fish. And everybody, and many people, I'm sure you do. Like if you go to Spain or Italy, they provide you seafood. It's amazing. So all those random, let's call it entropy. I don't know what that is, but entropy, sorry. But it is, it's something that we don't know yet. And I don't think, I think AI/ML or large language models are far from that.
Moving towards emotions, let's skip to the next topic, the value of human-made products. So as AI tends to make perfection the new norm, flaws and human quirks may become rare and exclusive. So we could be entering a world where imperfection is luxury, like handmade cars, and we already have that with Ferrari, right? Ferrari has a really interesting business model, right? Like they force scarcity in the market so they can increase their value or the value of their products, right? And there is a lot of handmade stuff and so on. So this is making it quite exclusive. So will human-made imperfect products become the next exclusive status symbols? What do you think?
What is imperfect? That's also something to evaluate. Handcrafted, from my point of view, handcrafted goods are going to be even more valuable because they have three important elements that, from my point of view, are key. So they are customized for you, they are unique, and they are scarce. And if we go and analyze the history, all the goods or all the assets that increase their value have these three characteristics. And the last one we see today is Bitcoin. It's scarce. It's kind of, gold, art. So I really think that coming back to what Mauro mentioned about Picasso, if you go to Guernica, that represents a very important part of our Spanish history, the Civil War. That's very unique. Probably it could be arguable if it's perfect or imperfect. It's just unique. And its value probably, cannot be measured.
But why is it unique, actually? Because nowadays, what prevents an AI to create or simulate Picasso?
Because it was created in a specific context, right? So Picasso left to Paris. There was a civil war. Guernica was bombed. Like all those emotions happen in a very specific moment of time that will never happen again, And he came up with this painting, and that painting has a history. It had to go to New York because he in his last willing, he wanted this to go back to Spain after Franco died. So that cannot be replicated, all the history. And we can talk about Picasso, but we can talk about something even more, let's say, ground to earth. The guitars. I play guitar, so handcrafted. If you have a luthier prepares handcrafted guitars, when you request him or her to prepare a very specific guitar for you, that's unique. It has your customized features. It has something specific for you. It's unique for you. So also Swiss watches. Now looking at Mauro, no, you Swiss are very specific on something which is very customized, handcrafted. They have high value. Ferrari. So I think handcrafted goods are gonna be even more valuable in the future.
Yeah, I agree. I agree with you. So if you think about, I was actually listening also another interview with Simon Sinek, and he was also stating, and I fully agree with him. I mean, people look at people. People want something from humans. And what makes us human, it's our imperfection. I mean, our imperfection make us human. And we will always search for our kind. We search for people with the same value. We because we feel at home. We are social beings, and therefore we look for this feeling of belonging to something, to somebody, belonging to our kind. And what makes our kind is our beliefs, our way, our values, and also our values. I mean, not everybody has the same values because it depends on those kind of imperfections, if you want to see it. I mean, seeing from somebody who has different values sees my values as imperfection, and that's the thing that makes us human. And also when you were saying about the luthier, I mean, every guitar is a different piece. And why is it different? Because it depends on the wood that has some imperfection. It depends on the glue. It depends of the mood that the luthier is building the guitar. And also I was actually talking to a friend of mine that has been playing the guitar for all his life, and he's also a teacher and so forth. And he says also the guitar with time sounds like you. If you play it enough in the way that you play it, the guitar will sound like you play it, just because of the sound that you produce, the kind of music that you produce. So it is an imperfection if you think about it. And that imperfection, and sorry to say imperfection, baby, that things that makes it different from one each other is the fingerprint. And we humans, we want that. We want this difference but alike. We search for something that is alike but has imperfection into that makes this characteristic. And also, if I want to say also because of the painting of Guernica of Picasso, I think because the feeling that he brought into the painting, many people actually reacted on the painting because they were feeling the same. So I'm not a psychologist, but I would like to speculate that people that find also that the painting, or they are fascinating by that painting, is because subconsciously it triggers a feeling inside of them. And that feeling comes from a feeling that Picasso has and was able to express it with the painting, with the shapes, with the roundings. And the human being resonates probably to those feelings. And that's why it made it so popular, because so many people suffered during the war in Spain and were able to recognize it and trigger something into them.
Couldn't that feeling being triggered as well if I now take an AI and replicate the Guernica from Picasso and I give it to you?
Probably yes. I mean, if you say, why not? Why not?
But then we are back to the discussion.
No, but what I'm saying is it can replicate it, but will it replicate it at the right point in time? Will it bring those imperfections that make us human recognize it? Mm-hmm. Of course, you could say, if you're able to model the brain, exactly all the variables that make us human, then of course, but then you replicate a human,
Mm-hmm. Giorgio, can I do a custom question for you in this matter?
Go for it.
If I create a program in the future, let's talk in the future, I create a program with Lovable or some other vibe coding tool, and I create a program myself, same program. I do it myself, handmade. Do you think people will pay more for my program? Or are we just talking about art and other things that create emotion in humans? But we know that software doesn't create much emotion unless it's making you save a lot of money.
That's a very good question.
I'm getting good at this podcasting thing, eh?
I don't believe it's going to be about, I did this 100% myself, didn't use a single external library, I wrote all the code in assembly, and reminds you of someone.
Yes.
Yes.
And neither is it going to be about, oh, look how quickly I did this shit. Well, sometimes the value the value tag you put on things is also based on what you as the maker, how much you value it. I think it's happening a lot now. Actually, let's bring some concrete example. We are talking about software, and it is already the case that through vibe coding, there are many things that have been copied a lot. There are some types of software that are being copied a lot. They're just become very easy to replicate. Maybe you could argue that they were already easy to build before, and now they are incredibly easy to replicate. And so there is dozens of, I don't know, CRM or issue tools out there, and the value is going down and down and down. All those tools, it's a race to the bottom. You can just make so many of them. But maybe in the end, where the real value will be making exactly the right software for the right niche, and the community that comes up around that software. Because software can also be something that unites people, and you see that already, because people tend to stick around software they like for various reasons, and it's not, oh, it's done 100% by a machine, and neither is it, oh, I did it 100% myself. It rarely is, except maybe a few games. There are some cases as such where people stick around that because of their love for the creator, because they really appreciate whoever made maybe that game. But I would argue that is a form of art specifically. But when it comes to software as a tool, a community tends to form around some very good software. Tech conferences come up. People stick around certain platforms because of the help they can provide to each other, or the knowledge you can transfer, or the fact that you maybe really appreciate the way software is built for your community, for your niche. And maybe the creators know exactly how to serve you, how to solve your problem better. And that's where it becomes valuable. So I think that is where the value is, where the creators, where the makers of some software manage to create somehow something human around it. And the fact that you use AI, it's like, okay, who cares? It's a tool. Usually users don't really care which compiler you use or which language you use, or
just the colors.
Just the colors.
Yeah. So another challenge we are facing nowadays is the loss of critical thinking, right? This happened already before AI, but with AI, it seems that it's getting even worse. And late studies, one from the MIT lately, show that relying on AI for decision-making leads to cognitive offloading, which means we stop thinking critically and remembering things ourselves. But researchers say that this isn't inherently bad unless we fail to fill those gaps with meaningful thought. Is AI eroding our minds, which is called, the concept is cognitive sedentarism, leading us to diseases like Alzheimer, or simply making us more efficient at the cost of deeper analysis? Mauro.
It's always, in a sense, it's always what you use your brain for. So if you use AI to do certain things, you will excel into using AIs for the certain thing. So for example, if you use AI to make decision and you let AI do it, you will become very good at providing information to the AI so that it can take decision, but you will not get better in doing the decision. And of course, it's, I mean, you hear it a lot. I don't know if you could say scientifically, the brain, it's like a muscle. If you don't train it, that it will start to get smaller. So to not work properly, to basically get dumber or chew out or whatever. And I always say this phrase. I don't know if it's very populistic in a way, that I say, nature is minimalistic. So it's like if you don't use something, then it vanishes. So because nature says, why do I need to keep it if I don't use it? So, and of course, it then goes back to the thing of like, what do you do when you use AI? It always depends. So it's not that it makes us dumber in a sense. It just depends how you use it. If like I said, if you use it not to take decision, if you use it to take decision, then you will get worse at taking decision, and maybe you get better in other things. So it just depends on you to take the decision of saying, what do I need the AI for, and how do I want AI to offload my brain to certain things? So and it's like when you use a calculator. When you use a calculator, then you're getting worse at doing like simple calculations and of course, but then you get better at doing other things. So it's just what you use your time for, or what do you use your brain during the time that you're using the AI or you're not using the AI.
Whenever I'm vibe coding, I take the time to post on social media. So
yeah, so you get better at social media.
And I'm getting worse at coding.
yeah, but it is like that, and that's why, for example, also when I think about it, when I use AI for coding some task, I really tell myself, no, I want to do it myself, and then use AI as a reference, because also then I should be able to judge what AI is doing, because if you keep just believing in AI, then you get worse at even judging what AI is doing. So
the problem is that I also use AI to post on social media. So maybe I should do something else while all these AIs are doing my work.
Then you get a super user in using AI.
Yes.
So you get better. You will be better at using AI. You know how to use AI to produce like very good posts. You know. But then the question is, how are you able afterwards to judge what a good post is?
Yeah. Juan?
Remind me the question again. Just,
we deviated a bit. So is critical thinking in danger?
Yeah. I mean, I will speak about my experience, because obviously your question it's a great question, but I'm afraid I don't have the knowledge to really answer it properly, but I will provide my own experience. As probably every immigrant that comes to a new country and has to learn a new language, right? In my case, I was fortunate enough to have to learn German. It's a difficult question. It's a difficult language, but very rich language. And there are many words in German that do not have a direct translation in Spanish. So meaning, when you learn a language, first of all, you need to feel certain pressure. Otherwise, the brain is not going to be able to remember the words. So if you're just in front of a book and read that, unless that you are, of course, gifted, you just read the book, the grammar, etc. Yeah, you may remember some words, but when you put them together, they might not make so much sense unless you go out there and then you put them in practice. And once you are in a situation where you need you're hungry, and you're in a country where nobody speaks your language and you have to use that language, is when the brain, as Mauro mentioned, oh, I really need now to speak German, otherwise I'm not going to eat. And it's when you remember it. So if you have an AI device that does this for you, first, you will not have that pressure, natural pressure. So AI will do it for you. So that means there is less effort that you have to put in order to get food in that case, right? So you don't have to remember the words because they are not so important. the factor or the problem here is not only that you don't remember those words, it's that you are, by not learning a language as well, not having access to that culture completely, not having access to how German people think. So why they put the verb in that position, why they have three genders, why, I mean, it's so much rich, or it's much richer to learn that language than having a device that translates it for you. Because all those subtle meanings in words and in culture, in the environment where you are, is what makes the language, the expressions that you want to say, super meaningful. And I think that's part of how our brain needs to adapt to new, let's say, challenges. So that requires, I'm sure, an effort. I mean, we all had to pass an exam. We all had to go through a language test. And if we do not put that effort there, I am completely agreeing with Mauro. Our brain will just not develop. And there are a lot of actually studies down there that once you put the effort, the brain adapts itself very quickly. It's constantly adapting. So if you don't use, it's for me, like if I don't play guitar for maybe 20 days, my fingers become slower. And then I cannot remember anymore, how to play Hotel California or the solo or whatever that is. So I think with the brain it's the same. If I don't speak German for like a month or English, I already feel it. So definitely there is certain impact in our learning rate and brain when we stop using it for certain activities. Now, I think AI probably will be great for redundant tasks, that do not bring so much added value. But I could not use AI for things that are important to me, that are super critical and relevant as a main tool. Or probably I will use it just to refine what I want to say, but not to get my core thoughts or my core knowledge from the AI.
So a free tip to our listeners: if you want to learn a language, you need to be traumatized by that language. Otherwise, you are not learning it properly, especially if it's German. That's a lot of trauma.
Or you need to fall in love.
Yes, that's another one. No, but it's quite interesting what you said about the language profiling the culture, right, of the people talking and speaking it. There is actually an interesting case of a tribe, I don't remember if it's in Africa or wherever in the world, that their language didn't have tenses, like there was no time. So for them, everything was today. There is no time, there is no yesterday, there is no tomorrow. And they were actually much happier. So it's interesting how removing time from your culture or your brain, or the concept of time, it makes you more happy, right? But anyway, Giorgio?
I also feel like sometimes the thing is, I would like to use AI as a sort of, let's say, superpower only. Sometimes I would really like to only use it for those cases, things that there is no way on earth I could ever do it myself, like translating ancient Greek, or reading an inscription and figuring out what it would mean, the context, doing the research. And there's just no way on earth I get all those skills in place to do that. It would take probably 10 years of getting a degree in ancient Greek history and studying the actual language and figuring out how to do research. For those cases, I don't feel like it's slowing me down in any way. In fact, I feel like it's a superpower. And this is actually a concrete it's a real example. I actually used it for that. So there are some capabilities that you could just not have before. Think about even when we initially had the internet, search engines and web archives and Google. I mean, doing research was suddenly very different. Even I remember that when I was a kid at school. Initially, we did our limit was the school library, basically, or the town library at most. That was it. That was the boundary. Then we got the problem is that then we got better tools. We got Google, and to be honest, nowadays I'm not so sure I would be able to go back and do a proper research, even with the limited tools that I would have. I wouldn't be able to do a, let's say, proper research, air quotes, but with different tools, with simpler tools. I don't know if I would be able to navigate the library anymore. Probably have to go and ask the librarian for help because I wouldn't know my way around. So I'm a bit scared about that. And I guess it just boils down to what we said earlier. If you don't use your brain to do certain things, it just drops them, or at least that's the feeling.
That's it for the first part of our episode on the future of AI. We hope you enjoyed it, and we will be back next week with part 2. If you like what you heard, let us know in the comments, and don't forget to give us 5 stars on your favorite platform. See you next week.